Hello, I'm Seongrok Heo, a senior research engineer at Hanwha Solutions wire and cable TM team. Today, I'd like to explain the degassing process which removes residual gases after manufacturing XLPE cables. High voltage cables require insulation materials with excellent electrical, thermal, and mechanical stability. To achieve this, LDPE is chemically cross-linked to produce XLPE. During this process, dicumyl peroxide is used as a cross-linking agent, resulting in byproducts such as acetophenone, alpha-methylstyrene, and cumyl alcohol. These byproducts can degrade insulation performance, so after cable manufacturing, a degassing process at 60 to 80 Celsius degrees for 5 to 14 days is necessary to remove them. First, space and time requirements. Degassing requires large spaces, potentially delaying production schedules. And second, shape deformation. During degassing, softened insulation may deform under the weight of conductors, affecting the cable's roundness. First, compound composition modification. Reducing the amount of cross-linking agents or introducing co-agents can minimize byproduct generation. Second, process optimization. Adjusting the cross-linking process to accelerate cross-linking in initial stages and remove residual byproducts in later stages can enhance efficiency. These methods depend on the cross-linking agent content and polymer characteristics, requiring prior simulation and collaboration with cable manufacturers for effective implementation. Hanwha Solutions Wire and Cable Division is committed to developing innovative products that maintain cross-linking degrees while significantly reducing the needs for degassing. We will continue our research efforts to provide such advanced solutions to our customers.